Let's click. Let's click.
Helo, pnawn da, croeso cynnes I chi gyd, diolch yn fawr yn ddod. Hello, welcome, good afternoon. Thank you very much for joining us. Peter Thomas ydw I, Bennaeth Sgiliau Gallu Digidol yn y Canolfan. I am Peter Thomas, Head of Digital Skills here in CDPS. We've got some people arriving as we speak. So we won't start quite yet. We'll give it another minute or so, but welcome. Dwedwch hello in the chat. Dwedwch pwy ydych chi, go ble ydych chi'n dod, say hello in the chat, please. Tell us who you are, what you're having for lunch, maybe. It's that time of day. What your interest is. Please use the chat throughout. And if you want to ask questions or make comments, please do so as usual. Croeso, croeso, welcome one and all. We are still seeing people arriving, and I know we've got some more due to arrive. But maybe take this moment or two to say hello in the chat. That would be good. It's great to know who's with us. We'll get started in just a couple of minutes. Not even that, maybe one. Let's see how we go. If you are arriving. Croeso, pnawn da, everybody, welcome. Hello, good afternoon. Diolch yn fawr am ddod. Thank you very much for coming. Are we looking at these in terms of numbers? We're on about...
Yeah, I think we're slowing down a bit now.
Okay. We go. Right, well then, without further ado, I think we'll get started. There's still a couple of people arriving. You can hear the beeps in the background, but Elise is going to be allowing everybody in. Croeso, pnawn da, hello, welcome, very warm welcome to you. Diolch yn fawr am ymuno ni. Thanks for joining us this afternoon. I'm Peter Thomas, Head of Digital Skills and Capability here in CDPS, and this webinar is all about an introduction to retrieval-augmented generation. So we will be using the chat today, so please feel free to dive in there. I've asked a couple of people already. Say hello, tell us who you are, where you're from, and use the chat throughout the session. Please ask us questions for David, our presenter today. We will be recording, so that should have popped up when you joined. We'll be recording the session and making it available later on. So, RAG, retrieval-augmented generation, AI, incredibly exciting, seems to be everywhere at the moment. Huge potential to be truly transformational in just about every aspect of daily life, or so the promise says. You've no doubt seen all the hype, it's all over the news, but today we're going to lift the lid a little bit, and David is going to take us through looking at a technique that improves the reliability of AI systems by using extra information from external sources. So I'm going to hand over to David Bash, data scientist with the Welsh Government, and I will be hovering in the chat and back at the end to offer him some questions. Croeso, David, welcome, hello.
Thanks, Peter. Yeah, hi, everyone. I'll just share my slides. See if that pops up. Yeah.
Yes.
Okay, great.
Thank you.
Thanks. Okay, so hi, everyone. Welcome to the latest data science webinar session. As Peter said, it's a session on retrieval-augmented generation and how we can use it to improve our large language models' performance. Just a quick mention of the CDPS YouTube page, first of all, where you can go to watch previous data science webinar videos that are hosted there, as well as a bunch of other really useful videos on a really wide range of topics. So I would encourage anyone to check that out when you get the chance, because it's a great kind of resource for more content like this. So just a quick presentation overview now. So first of all, we'll look at what RAG is, and then we'll look at why should we use it. Then we'll be looking at how does RAG work, and then the architecture that kind of makes it work. Then we'll have a look at a practical example, and we'll have a look at actually a couple of practical examples today that showcase why RAG is useful and how we go about using it. We'll take a look at some of the ethical considerations briefly towards the end, and then we'll summarize everything that we've been through. And then we'll have some time for questions at the end as well. Although I think we have some of my colleagues from DSU here in the chat. So if you have questions as we're going through it, please feel free to put them into the chat. So start off then, what is RAG? So traditional LLMs, they tend to use data or only use the data that they were trained on. And because of that, the information that they can reference can become outdated relatively quickly. So the idea behind retrieval augmented generation then is that we let the language model look into an internal knowledge source at runtime, or that is when we prompt it, it can have a look at the knowledge source that we provide before generating an answer. And by doing this, it can include the latest kind of information that isn't included in its training data set, as well as kind of domain-specific facts before generating its final response. So it's a really helpful tool in getting our language models to maintain accuracy and relevance in its answers, even if the model's core training data is quite old. By providing the external data source, we can give it up-to-date information on events and data that happened well after its kind of training data cut off. So just to kind of help explain what I'm talking about a little bit, this first diagram here is a really high-level example of an LLM with no RAG. So on the left there, you see the prompt that comes from the user that gets submitted. The prompt is kind of understood by the LLM, and they generate an answer based on its training data, solely on its pre-trained knowledge. There's no kind of interaction at this point with external sources. The answer is generated, and then it gives it out to the user. And then if you contrast that with this diagram here, so this is another high-level overview of an LLM system, but with RAG in place. So the prompt's fed into the system. Embeddings of the prompt are compared against the embedded text in the data store, and the semantically closest results are returned back to the LLM to help augment its answer. And there's a few kind of words in there that may or may not make sense to you, but I'm going to go through them a little bit later and explain exactly what each part is doing. But that's just to kind of give you a really high-level example of how RAG differs from an LLM without RAG. So why should we use RAG then? So as I kind of hinted at, there's traditional language models have some limitations that are pretty well known by now, I think. So they're really, really good at generating lots of coherent text, or text that sounds kind of correct when you read it, especially if you don't have that much knowledge of the domain that you're asking the language model to talk about. But the training data, as I mentioned, is fixed at a certain point in time, so they can't easily access newer information or anything that's kind of happened after that cutoff point, or even if it happened during the period of time where the training data is taking place, it's not exhaustive. So there might be specialized kind of domains and other bits of information that they haven't been trained on, and then they'll never be able to access that because it's not in their training data. So they're also prone to hallucinations, meaning if they don't know the answer to something that you ask, they're really good at kind of fabricating an answer that sounds right. But when you look deeper into what they're actually saying, it's just, well, nonsense some of the time. So they're two of the kind of main reasons why LLMs can get a bad rep sometimes. And they can kind of get in the way of really reliable uses of LLMs. And that's what we're trying to mitigate against by introducing these RAG elements into our systems. So in cases where, like I just mentioned, where the language model is missing specific knowledge, like a recent event or say a policy document that's very specialized or unique domain data, something like that, there's two kind of main ways that we can fill that gap. So the first is to fine tune it. And that means we retrained the pre-trained model on a smaller kind of focus data set based on whatever we want to kind of enhance the knowledge of the LLM on. It can provide really good domain-specific understanding, but it's often quite time and cost intensive. And it also introduced other complications as well, such as you have to manage the model versions and retrain whenever new data appears. So especially in kind of domains that are changing really quickly over time, it can become quite difficult to stay on top of the fine-tuning and the retraining, while also managing the kind of time and cost intensiveness of those things. So then the other option that we have is RAG, or retrieval-augmented generation. So instead of retraining, we give the LLM direct access to our data source. And that can be like proprietary data or external data, or pretty much any kind of data that we want to give it in text format. And this can be more efficient than fine-tuning because we don't need to alter the core model at all. We just put our new data into a folder and point the LLM at it. And then essentially we provided everything the LLM needs to kind of reference the data that it didn't have in its training data set. So fine-tuning and RAG, they're not mutually exclusive, I should say, but they're often, you choose one or the other when you're kind of starting to build a product with LLMs. But there are options to kind of go with a hybrid approach when you use both of these things. But to keep things simple today, I'm going to kind of talk about why you might choose RAG over fine-tuning and the benefits of that. So fine-tuning effectively, it merges new domain knowledge directly into the model's parameters by retraining. And it works well, like I said, in a stable or well-defined kind of area of expertise, but it's really resource intensive and time consuming. And every time you update the knowledge, you typically need to retrain or at least refine tune the model. And the larger and more specialized the data set that you're trying to retrain it in, the more effort and cost it takes to do that retraining. And then RAG, on the other hand, it allows the model to retrieve context and information on the fly or at runtime from an external data source, which means less overhead because you're not constantly retraining the entire model. Instead, you're just dropping new files into the folder. And it's really good for domains where information changes a lot, since you can swap or add documents really easily. But like most things, the decision comes down to your use case, the infrastructure constraints that you're faced with, and probably more importantly, how static or dynamic the data is that you're trying to get into the LLM. So in this section, I'm going to go through a practical example, and that will hopefully help to highlight the different stages of the RAG system in action and help to make it clearer exactly what's happening behind the scenes when you implement something like this. So just to give a really high-level overview of what's going to happen then. So we want to read in some text documents. We want to chunk them, which effectively means to split them up into smaller bytes. We want to embed these chunks into vector representation and then build an index from the embeddings that we created. We're going to take the user prompt and embed that as well into the same space as the documents that we've chunked up, and then retrieve the most relevant or semantically similar text chunks from the index that are the closest to the prompt that we provided. And then we want to engineer a prompt so that we have the retrieved text from our vector database, as well as any kind of system prompts to help guide the LLM and the user query. And we're going to pass all of that back to the LLM. And then hopefully it will generate a contextually relevant response based on that. So for this example, I've chosen a recent article from the Welsh Government website that's talking about turbocharging AI in the UK. So this is quite a recent article released on the 13th of January. So I think most LLMs that you use now would probably not have this in their training data set. It'd kind of be beyond that time frame of data that they've been trained on. So the first step is that we take the text from the article and we chunk it. So instead of dealing with one really big document, we break it down into smaller, more manageable pieces of text. And this helps our system to kind of focus on the most relevant sections during retrieval. So when we go in and retrieve certain text chunks, we're not getting masses of text just to answer one question. We're really kind of pinpointing the information that we need and only returning that. And doing it this way helps with various kind of processing steps throughout the RAG system, but it also helps us to speed up indexing and processing. So there are a lot of different chunking strategies that you can use, but the one I've used here today, it's quite a small document that we're breaking up, is to split by sentences. And when you think about things like context limitations and context windows with LLMs, you have a certain amount of space to work with. So exactly how you chunk them up, how you chunk the document kind of depends on which LLM you're working with and what the kind of desired result is. So after we've chunked them up, the next step is to convert each chunk of text into a text embedding. And a text embedding is a piece of text that's been projected into a higher dimensional space and then represented by a long sequence of numbers, a vector. And the idea is that texts that are similar to each other semantically end up being positioned closer to each other than less similar items in that higher dimensional space. So semantically similar sentences should have similar embedded vectors and be closer together. That's the idea. And then these vectors, after they've been embedded, can be stored in the vector database. And that's where these similarity searches will be performed later on to find the text that are most similar to our query. And I've got a little diagram here to kind of just help explain embeddings a little bit more in case anyone isn't too familiar. So on the left, you can see some words there represented by numerical values across several dimensions. For example, bunny might have higher scores in the dimensions like alive or mammal, while hutches has a really different distribution because it's not alive or a mammal. So these scores are an example of the dimensions that we use in embeddings to capture the semantic properties of the words. And often when we're doing this in kind of production or in practice with real data sets, the embedding vectors end up really high dimension. So often hundreds of dimensions as opposed to what we have here, where we have just the 6 different dimensions. And so after we kind of get those vector embeddings, before we can visualize it, we need to reduce those hundreds of dimensions down. So we do some dimensionality reduction. And then after that, we project them into this 2D space that you see on the right here, just as a way to visualize and get the kind of an intuitive sense, I guess, of how similar or different the words are. So you can see there on that top 2D space on the right there, we have bunny, rabbit, and hamster that have been kind of put next to each other. And then you have hutches, which is kind of the odd one out as it's not alive, in that top right corner, further away from its bunny, rabbit, and hamster data points. So after the embeddings have been stored, after the embeddings have been made, we need to store it in a vector database so that the LLM can reference it. And if you remember back to the start of the presentation, we had those examples of an LLM with RAG and without RAG, and we have this little data store module at the top here in the LLM with RAG diagram. And that's where these embeddings are going to be stored. So how it will work is the user prompt comes in on the left there. And before the LLM starts to generate its answer, it will embed our query, compare it to the embeddings in the data store, and pull out the most semantically similar chunks of data from that data store in order to augment its generated reply. And with the embedding sorted out, we need the other kind of core piece of RAG module, which is our retriever. So it's essentially just a search function written in Python here. And this takes our prompt and embeds it into the same space as our data store, and then finds the most similar embeddings in the vector database and retrieves them to provide them as context to the LLM. And we can customize things like the number of chunks to retrieve from the database at a time, which is quite important to consider when thinking about things like context length of the LLM, and also processing overhead and things like that. So let's test out the retriever then. Here's an example, and you can see the question there is, what is the UK AI Opportunities Action Plan? And that is the name of the plan from the blog that I mentioned earlier. So we submit that to our search function, our retriever, and it will look in our data store for the most semantically similar chunks and then return them. And you can see the distance column there in those returned results shows a number, and that is representing how far semantically the text chunks are from the query. So the lower numbers are closer to the query, the higher numbers are further away. And then after we get those kind of results from our data store, we engineer the prompt then so that we can pass the retrieved context into the prompt, as well as any kind of system prompts to help guide the LLM in the tone or any other kind of specifications that we want to pass in. And then the user query as well. And we pass all of this to the LLM, and hopefully we'll get something good out. So we can see here an example of a reply from the LLM, and we can see the answer looks pretty good. So it does in fact pull out the right information. It says the UK AI Opportunities Action Plan is a government initiative launched by Prime Minister Keir Starmer. And then it has some more information there that is pulled out from the article that we've chunked up. It's important, I think, to note that it hasn't just copied the context directly. It hasn't just kind of copied and pasted it into its reply, but it's properly augmented a brand new generated reply with the information in quite a natural way, really. And another thing to note, again, is just to reiterate, this is a new story that's been released well outside of the date cutoff for training data. So if you put this question to a LLM without RAG, you might see a very different kind of reply. And we'll see an example of that shortly. Now, in fact, so how would this look without RAG? So this is the same thing, but we've submitted the question to an LLM without any kind of RAG. So no data store, no text embeddings from the article. It's just based on what it's been trained on in the base LLM. And you can see here, it's got the name right because it's inferred it from our question, the UK AI Opportunities Action Plan. But then it started to say, also known as the Sector Deal for Artificial Intelligence, which is hallucination, was announced by the UK government April 2018, another hallucination. And that's the kind of example of the limitations of traditional LLMs that I talked about earlier, where it will give you an answer that sounds right. If you didn't know about the Opportunities Action Plan, this might seem right to you because it's just put together in such a way that it sounds confident and it sounds correct. But because it has no actual data to reference about the event, it's completely wrong. So let's try another one then. This time the query is, how many jobs will the UK AI Opportunities Action Plan create in Wales? So again, we submit it to the retriever. The retriever goes to our data store and finds the most semantically similar text chunks to return back to us to pass to the LLM in order to help it generate a coherent kind of accurate answer. And again, we get the distances back where the lower scores are closer to the query. And we've returned 3 because that's how many we've specified in our search function. Again, we can change that as we want to. So in this one, it's slightly different. So I printed out here the retrieve context first. So this is the text chunk in its raw form taken from our data store. And this is what gets passed to the LLM in the prompt. And it's quite difficult to make out, but you can just about see in the retrieve context, we have like over 11,500 jobs that are going to be created in Wales as a result of this new plan. And then at the bottom there, you can see the answer that's been augmented with the context from the LLM. And again, it's talking about the creation of over 11,500 jobs in Wales as part of the Opportunities Action Plan. And another good thing that it's done here, I think, is it's managed to reduce the retrieve context content down by a whole lot. A really small summary version of it, but while still retaining the fact that we specified in the query. So it's done really well, I think, at creating a shorter but still accurate answer there. And again, we can try it with a base LLM with no RAG. And this time we get an answer that sounds right, but it's been hallucinated. And it says, the action plan does not specify a particular number of jobs that we create in Wales, which is very factual sounding, but incorrect. So moving on to RAG architecture then. So RAG systems can differ a lot in how they're built. You can make them extremely complex in terms of kind of multi-hop queries and refining the text and lots of other kind of cool things that you can do with LLMs. But they all share the 2 fundamental components, the retriever and the generator. So I touched on it earlier. The retriever is the search function that's going to search our knowledge base or the vector store to find the most relevant information matching the user query and return that to the LLM. The second is the generator itself, which is the LLM, and that uses the retrieved information passed to it by the retriever together with the user's query and also maybe the system prompt to create a response that's grounded in facts that we've provided. So it provides the final answer then and makes sure that it's up to date and contextually relevant to what we're actually asking the LLM to do. And I think at this point, it might be useful to go through this diagram real quick. It's just showing a basic RAG workflow, just to help conceptualize visually what's kind of going on. So on the left-hand side here, you can see the raw data sources. We put them into our system. The text is extracted from them. We chunk the text, as I mentioned before, splitting the larger documents into smaller manageable segments. We embed those chunks, which, as I mentioned earlier, it's encoding it into a high dimension vector, such that semantically similar text end up next to each other in the embedding space. And then they get stored in our vector database. And then if we move over to the right here, this is the user query or the prompt. This gets embedded into the same space as our evidence chunks over here. And it's matched against the vector database to find the most semantically similar data chunks. And then they are returned in the prompt to our LLM, along with anything else we want to give it, like tone indications, etc. And then together with the evidence, the prompt and the user query, the LLM will generate a contextual response to our question. So this is just a little look at if you're using RAG, you have an option basically to code up your own version from scratch, or use an off-the-shelf product. And it's still quite an early days, I think, in the kind of off-the-shelf offerings, but I think there's still a decent kind of amount of offerings out there. For example, Copilot is one that we'll probably all be familiar with. That offers a kind of basic RAG implementation where it says you can upload a document here and ask me questions about it. But there are obviously benefits to that, but I think there's also benefits to the custom code RAG, and which one you choose kind of just depends on a lot of things. So I'm not going to read through all of this here, but some of the points to consider is that the custom code version would be more flexible. You have more control over things like indexing and embeddings, prompt engineering, and things like that. It's just easier to kind of customize it to your own use case. Data security then is another important one. You control the hosting and the data flow in the custom approach. but the off-the-shelf solution may have some kind of data routing through the vendor's servers or things like that might not be obvious to you to begin with, but could raise kind of privacy concerns with the data. And then cost and time to market are really important as well. So I think the custom solution has the kind of higher upfront development cost just because of the time that it takes to develop. And of course, you need people with the skills that will allow them to develop them. And off-the-shelf platforms usually have its subscription fees and things like that. But the bottom line, I think, is the custom solution gives you more control and security, potentially, but demands more development effort. And the off-the-shelf solutions give you a really fast and simple startup, but the trade-off is flexibility and customization. So as always, with things like this, I think the best choice really just depends on your use case, the data needs, the budget, and the timelines that you're working with. So move on to a practical example now. So again, a reminder of the high-level overview of a RAG workflow. So we read in the documents, we chunk them, we embed them, we build an index from the embeddings. We take the user prompt and embed that and retrieve the most relevant text chunks from the index. And then we include the retrieved text chunks in our prompt to give the LLM context and pass everything to the LLM and let it generate us a good response. So this time the example is a collection of data science unit blogs from the digital and data blog. Excuse me. And we're extracting the text from these 3 different articles, combining it and using that as our starting corpus. And again, just a quick reminder of the what happens visually with RAG. So we get the data in, we extract the text, chunk it, embed it, store it in the vector database. We take the user query, embed it in the database, and we pass everything, the semantically closest text chunks to our query back to the LLM and ask it to generate us a response. So here's a practical example then. So we've asked it there in the query, what is CAS styles are? And those of you that may be familiar with the DSU will know that it's a package put together to help style charts and things like that and reports to the standard of Welsh Government. And you can see there that the answer that is given us is CAS styles are as a code package developed by the data science unit of the Welsh Government, written in our programming language and all the rest of it as well. And again, if you submit that question to a base LLM, chances are you'll get some kind of hallucination or a lower chance, but still possible. It might just say it doesn't know what it is. So let's move on to another example. So this one is a bit different because we aren't looking for a specific bit of information. Instead, we want the LLM to look at the data that we provided it in our data store and kind of infer an answer based on the context, but without necessarily taking specific facts from it. And we've said, what kind of projects do the data science unit work on? And it's come back with a pretty good answer. The data science unit works on projects that aim to modernize data usage, enhance efficiency, and promote automation within the public sector. So again, it's done pretty much spot on there. And we can also see in the reply where it says document 3, we can see that the LLM is using in-text citations to reference the documents that it's pulling the fact from. So actually, if we were still unsure of its accuracy, we could go back to the documents that we put into our RAG system and check the actual document to make sure that the information lines up. So in this one, we're asking who works in the data science unit. But because the data we provided didn't explicitly contain the author's full names or they've been redacted, the LLM really struggles to pull out a detailed answer and instead talks about the type of people who could potentially work there. So this is an example of it not working so good, but actually it's by design because we've removed those personal informations and it hasn't been able to kind of pull them out. And on this one, we're asking what is last ancient woodland. So a base LLM might see that question and start talking about woods that haven't been found or have been lost to time, that sort of thing. But because we've provided the blogs as context, it knows that we're actually referring to a specific kind of thing in the Last Ancient Woodland blog. So areas that were once forested land as depicted on old maps, but no longer exist today. And that's an example of an LLM taking something that could be construed as maybe a generic question, but it knows that we're looking for specificity in this case, and that we want it to check the context that we provided before answering. So next is evaluating RAG. So there's a Python package called RAGAS, which is what we're going to be talking about today. And this is retrieval-augmented generation assessment suite. It's a Python library that provides a few metrics that have been specifically designed for evaluating RAG systems. So the main focus areas are factual accuracy, so checking if the generated response is correct, query relevance, so making sure that the answer is related to the query and directly addresses it, and context effectiveness, so verifying that the retrieved context is actually contains the answer and is helping the LLM to ground the generated reply. So by using RAGAS, we can use, we have a way of measuring how well a RAG pipeline is performing in practice. And it can also help us to find areas in which the RAG system might be performing poorly so that we can refine it. So some examples of the metrics then. On the generation side, we have faithfulness. So that assesses how factually consistent the answer is with the retrieved context. The answer relevancy measures how closely the answer aligns with the user's query. And on the retrieval side, we have context precision. So that's the proportion of retrieved chunks that are actually relevant to our query. And context recall, which evaluates how many relevant documents were successfully retrieved out of all the possible relevant ones. And this is a toy example that's showing the evaluation in action. So we have the query that we asked the LLM in the top there. We have the ground truth, which is provided by a human, so the actual real answer verified. We have the answer that the LLM provided, and we have the retrieved context that the LLM has used to provide those answers. And after you run the evaluation, it will provide these metrics back, like answer relevancy, context precision, faithfulness, and context recall. So the relevancy here is really high because the answers that the LLM provided us with in the same kind of context as the answers that the question that we asked, sorry. And the faithfulness is also high because the facts are verifiable in the context. The facts that the LLM has answered are verifiable in the context that it's retrieved. So in this example, it's pretty much the same data, but I've went into the LLM answers and manually changed them to be wrong. So factually wrong, but the surrounding text is still the same, so it's still somewhat relevant. And you can see that reflected here, where the answer relevancy is still high because it's seeing all the right kind of words that are to do with the question we asked. But the faithfulness here has dropped to 0.16, which is showing that the facts here, so I've changed 11,500 to 11 jobs, are not verifiable in the context. Because this is a toy example, the context recall and the context precision are pretty much perfect, and that's because we don't have that many chunks of text to work with. So actually, we're returning everything, essentially. So moving on to ethical considerations then. I think a lot of these have crossover with kind of other AI kind of domains, but I've tried to make them as related to RAG as possible. So whenever we select the documents for retrieval, we need to make sure that they're coming from a wide array of sources, because obviously if they all come from one place, we can end up with biases in the data, and the retrieval process can unintentionally amplify them because that's all the data it has to work with. Hallucinations then, RAG can help reduce hallucinations by retrieving the context, but it doesn't eliminate the possibility of hallucinations entirely. So if the data source itself contains inaccuracies, or even if the model misinterprets the data source and comes up with an answer that isn't true, misleading content can still kind of creep into our outputs. In the privacy and compliance area then, if the sensitive or personal data is fed into the retrieval pipeline, there's always a risk that it's going to come out in some of the generated text. So like our full names in our blog, we need to redact personal information so that it's not going to be used by the RAG system. And then Welsh language considerations. So it's really important, especially in Welsh Government, to make sure that all different language queries are treated with the same quality standards as the English queries. So we need to verify that responses in Welsh are as accurate and contextually as rich as the English responses, and that the model isn't biased towards English sources. So at the moment, this is quite difficult because of a lack of models trained in Welsh, but there's a few different kind of agreements ongoing where Welsh language models have been agreed to be developed. And so when these come to fruition, I think it will really help mitigate against some of those bilingual challenges that we have. And so, yeah, we've reached a summary now. So I'll just summarize the things that we've gone over and then pause for questions and anything else. So to reiterate then, the core concept of RAG, it combines external knowledge sources with large language models, and it helps us to tackle issues like hallucinations, reliance on outdated or incomplete training data, and make sure that the LLM replies that we're getting are more grounded in relevant context than they would have been with the base LLM. The key benefits to using RAG is contextually relevant answers by retrieving the up-to-date information from our knowledge bases, reduced hallucinations, easy domain adaptation. So instead of retraining a huge model for every time we want to change domain or introduce a new kind of concept, we instead can drop documents and information into our data store and have the LLM reference them in real time. Evaluation and metrics. So we looked at RAGAS and how it uses metrics for generation and context retrieval to tell us how well our model's performing. And on ethical considerations, then we had a look at the need for diverse data sources, the risks that we have around hallucinations still creeping in, privacy concerns with the data that we store in our data store, and the redaction of that data when it's personal, and also the multilingual inclusivity to make sure that we're ethically kind of deploying RAG in kind of multi-language organizations. And that brings us to the end. So thank you very much for listening. I hope you found something valuable to take away. And please don't hesitate to follow up with any questions to our email in the chat or through CDPS. And I'll hand back to Peter now.
Fab. Thank you very much, David. That was great. Fascinating. I've got a question, but I can see James from Health Protection from Welsh Gov has a question in the chat there. James, do you want to come in? Because I think we've moved on a little bit from when you asked that question. But essentially, it's what tool do you use to ask the questions and get a response? James, do you want to add anything to that?
Well, I was just asking on the practical side where you was showing a code. So I was wondering, is it still under development in Python, or there's a tool that people can use?
So at the moment, this is just the kind of toy example of a chat interaction with the LLM made in Python. It's not been released at the moment, but there are a few projects that we are working on at the moment with a similar kind of interface that could be released down the line. So if you're interested in kind of looking into that, we can keep you updated with the developments as they come.
Okay, that's great, thank you. So my question, Dave, is back to the beginning really, which was about chunking, and that fascinates me. So your example was sentence by sentence, but what's the impact of that? You know, if you were to paragraph at a time or words at a time, do you know what I mean? Extremes. And what you do, how do you actually do it? That's my bit really. What do you use to chunk the text?
Well, I've used Python in this case because
Right.
the kind of whole project is done in Python.
Okay.
And it has a lot of really good kind of string editing functions built in to the base code. So it lets you just really kind of manipulate the strings however you want. As far as the effect of the different methods goes, I think it really depends on the use case. In this one, I think it's worked well to use sentences because the document's quite short, and also because the LLM that I was working with has quite a small window of text that it will take in. So we want the chunks to be as small as possible. But then some more modern LLMs will let you put in like loads and loads of text. So in those cases, maybe it would be more prudent to have larger chunks of text. But then, of course, you have the trade-off of having more information included in each chunk. So when you're retrieving the chunks, you end up with all of this information that isn't actually relevant to the one question that you're trying to get the answer to. So really, it's kind of experimentation, trying different size chunks and how that affects the output from the LLM and going from there, really.
Okay. Yeah, that makes a lot of sense. Thank you. Okay, brilliant. Right. Any more questions, please, while we've got David live on screen? Yes, Harriet's here. Hello, Harriet.
Oh, I think you're on mute, Harriet.
Totally right. Hi, David. It's really interesting, that kind of whole world of the level, I mean, how much we can trust what we get, how we respond to what we get from our questions to AI systems. And I kind of try to, at the moment, I'm trying to kind of encourage people to think of these systems certainly as we use them in business and in, you know, as administrative tools or to help us with documents or interpretation or whatever, to view these tools as sort of like, this is a kind of reduction, but as kind of like a kind of very bright, very enthusiastic, very fast intern who you'll ask to do something for you, and they'll rush away and do it really quickly and come back to you like pant back up the corridor with this great, you know, piece of work. And my kind of encouragement to say, see them as that intern, see them as this incredibly bright person who's really quick, but you still need to bring your human knowledge and analysis and experience, you know, of whatever field you're in to bear, to check and review and kind of, you know, it's really helpful first drafts of things, really helpful kind of, you know, speed me up on this, get me up to speed quicker, but always with that kind of, but I'm going to apply my own knowledge to this, and if it doesn't feel right, it may well not be right. I'm just wondering what you thought of that approach.
Yeah, but I think spot on, really, especially with base LLMs, is exactly right. Very confidently delivering information, but it's not always correct. And RAG isn't a way to kind of get rid of that completely, but it is a way to mitigate against it. So the amount of information that is wrong or incorrect will lessen with RAG. And of course, you also have, even with these kind of evaluation metrics that I was talking about, and even with RAG, you're always going to need the human there to kind of verify the final output. I think we're not quite at the spot where LLMs with RAG could replace a person. I don't think we will be anytime soon, because we always need, like you say, that human oversight to check the facts and verify things. Even if we can automate a lot of it, we're always going to need a human in the loop to kind of verify the verification, if that makes sense.
Thank you very much. Any more? We've got one from Mark. Hello, Mark. Mark Lester, coming in, please.
Hi.
Hi,
Thank you very much for that. I'm asking a question here, but as a person, obviously, you think we're up to learn Python.
Oh, Mark, I'm really sorry. Your signal seems to be dropping out.
Yeah, I'm sorry.
We're hearing.
Wait a second. I think it's because where my mic was. Can you hear me a bit better now?
That's better, much better. Yeah,
it's fine. It's because I didn't have my other headphone in. So as a person that is obviously, you've been immersed in this world for a long time, where would you recommend for somebody who was approaching particularly Python as a language, where would you recommend they would go and learn about that?
It's a good question. There's so much information out there now, with how popular LLMs are. I think a book is always a good place to start. But personally, I like the O'Reilly books. I don't know if you've seen them, but they cover a lot of topics and they have an animal on the front usually. And there's LLM specific ones that are really good, that are quite recent as well. I think if you want like a less kind of overwhelming experience, introduction to them, YouTube is a good place. Yeah. And articles are pretty good as well at kind of providing summarized versions. So things like Medium, or if you just put in kind of LLM Python into Google, I'm sure you'll get like loads and loads of results that you can have a look at. But yeah, for me, I like to have a book as kind of the source truth, and then for other things, kind of search around, and almost like the RAG system itself, you need to go back and verify the things to make sure that it's not just nonsense.
Yeah. Oh, bro, thank you. Appreciate it.
No worries.
Hey, another one coming in now. Thank you very much, Dr. Roberts. Hello, Owain.
Hello, pnawn da. Thanks very much for the talk. I'm Owen Roberts. I'm from the National Library of Wales. I just had a question really around the relationship between the LLM and the retrieval system, and to what point are they sort of, to what extent they're integrated, and whether we foresee or does this exist already, a situation where you'd have a specialist RAG system that services many LLMs, and how do you see that developing, how that could develop over time? I don't know if that makes sense as a question.
Yeah, no, definitely. So yeah, they're separate. I kind of touched on the custom code versus off-the-shelf options. And in the custom code one, you have like full control over the retriever and the embedding vector database that you use. And there's all different kind of packages out there and things that have been made already that you can use straight away without much development. So the option to switch out the retriever module and the database and things like that is there if you're building it from the ground up. In terms of using different LLMs in the same system, there are these things now called SLIMs, they call them, which is like a smaller version of a language model. And they've been trained to just do one thing very well. So, for example, to summarize text really well, but maybe not do anything else. And the most recent RAG systems that you'll see will have a really quite intricate system of multiple language models doing things that they've been trained to do and only do that, but do it really well. And the idea is to get the processing overhead way, way down. So yeah, there's definitely scope for it. I think it's still in early stages, but it's definitely the way that it's going to have that kind of multiple LLM system working with a retriever and all the different parts working, kind of focusing on the one thing that they've been put there to do.
Brilliant. Right. Thank you very much. Okay, very last chance if you've got a burning question, because we are very close to time and I'm going to move us on if I see nothing in the next 5 seconds. So if you're ready to ask, pop that hand up or type frantically in the chat. Otherwise, I'm going to ask Elise to pop onto the next slide, please, because we're just going to finish off then. Diolch yn fawr iawn. Thank you very much to David for presenting and the data science team for all the work that goes into putting these together. We always ask for event feedback, so if you can spare us a couple of minutes just to scan that code or click on the links that have just appeared in the chat, tell us what you thought, tell us what you missed, tell us what you liked, tell us what you didn't. It really, really helps. So please take a moment just before we finish, take a scan of that with your camera or give us a click on the survey, please. And then in just a moment, I need to make an advert. So we've just published some AI guidance. So if you are, like many people, swamped by the world of AI at the moment, there's so much going on. This guidance has been pulled together by CDPS using UK Gov guidance. So we've aligned with that very strongly, but we've made it into something that's accessible for Wales and relevant to Wales. So this is on our site. It's in a beta format at the moment with a feedback option built in. So what I'd like you to do, please, is if you get a chance, click on this, and the link's in the chat again, have a read. It's in English and Welsh. Read through, see what's good, see what's not so good, see what's missing from your point of view, and please let us know. Click that give feedback button, because this is meant to be pan-sector guidance, it's central guidance. It's almost like a hub and spoke model where this is the hub and it will link out in future to sector specific guidance or health specific, local authority specific, or, you know, that's the idea. But it's up and it's live. We'd love your feedback. So that's available now. Links in the chat, as I say. It's in our service manual and the guidance and standards on the CDPS website. Many, many thanks for that. And I think we've got one last advert, which is this. So AI will no doubt affect all sorts of organizations and the people who work in them. So I'm one of the team that's been working on the Workforce Partnership Council's guidance around the impact of AI on the workforce. I'm delighted to say I've got colleagues coming to talk about these impacts. So if you're interested in what AI might mean for your workforce, for the people who are going to be using it, or the people who might be fearing their jobs might be affected positively or negatively, then this is a great opportunity to come and have a chat and listening on what those reports are all about. 10 a.m. on the 20th of February. Put it in your diaries now. Okay, we are bang on time, I think. I don't think there's anything else left to say other than diolch yn fawr iawn. Perfect timing, Elise. Thank you very much. Diolch yn fawr am ddod. Thank you so much for coming. Thank you very, very much again to David. That was absolutely fascinating. And as was mentioned, this has been recorded. It will be up on our YouTube site for you to come back and refresh your memories, or pass on to people if you think they've missed out. So, without further ado, diolch yn fawr. Thank you very much. Have a lovely rest of the day, and we'll see you in the next one.